So I'm going to go back into our sequences and series note sheet, and we're going to continue on that. And so in our last class, I believe this was the last example we did where we were finding summations, okay? And these summations were arithmetic, and I'm going to talk about those in a little bit of review in just a minute, but just to give you an indication on your notes. But I also put together this set, and if you don't have these written down, you should definitely write them down, because we're essentially doing 4 types of problems. Okay, there's an arithmetic sequence, a geometric sequence, and an arithmetic series, and a geometric series. And so, judging from what we just practiced on the Kahoot, you guys are pretty good at determining whether something is arithmetic or geometric. It's arithmetic if we add the same thing each time. It's geometric if we multiply by the same thing each time. And so if you're just trying to find a term, that makes it a sequence. What makes it a series is if you're trying to add them all up. Okay, so you first determine whether or not your string of numbers is a sequence. I'm sorry, if it's arithmetic or geometric. And then once you figure that out, is it a sequence or is it a series? And then you would know from there which of the 4 formulas are we going to work with to be able to figure out our problem. So the last formula that I hadn't given you yet, you guys should write this down. And well, let's see, we'll make it a different color since this is new for today. Let's say S sub n, this is for a geometric series, is equal to a sub 1 minus a sub 1 to the r, I'm sorry, a sub 1 times r to the n power, all divided by 1 minus r. And now that you have all 4 of these in a single place, make sure you can find that in your notes, okay? Because this is we're going to use, we kind of have all 4 of them in one spot, and it's more concise as opposed to scattered throughout our notes like we had before. So today's idea is about a geometric series. So I'm going to just write our notes here, geometric series. And let me give you an example of what we would be talking about. All right, we want to find the sum and as I'm reading that, as soon as I see the word sum, I know it's a series and not a sequence, okay? Because sum means adding them up. So find the sum of the first 7 terms of this string of numbers, 14, 56, 224, and let's say that that is our pattern. So we want to find the sum of the first 7 terms. I mean, it gives us 3 of them. I could just add those 3 together and then figure out the next one, next one, next one, and add all 7 together. But I'm going to use our formulas, and maybe if I get good at that, it'll be a little bit quicker. So the first thing is determine if it's arithmetic or geometric. And you guys are smart, of course. It's going to be geometric. It's in that section of notes. But the reason it's geometric is because we have an R value, meaning if I did this number divided by this number, so 56 divided by 14, and let me pull up my calculator here, okay, just to go through these. So what I would do is take the second term, 56 divided by 14, and that comes out to be 4. And then I'm going to double check and do 224 divided by 56 and see if I get the same R value. So if I do 224 divided by 56, I get the same thing. So that means that my R is equal to 4, and it's geometric. Now I know that R is equal to 4. And I've determined it's geometric. I'm going to use that formula that we just talked about. So it's going to be a sub 1, which remember means the first term, right? So where's the first term? There, it's 14. So it's a sub 1 plus, I'm sorry, minus a sub 1 times R to the n. So minus a sub 1, which is 14, times R, which is 4, to the n power. And that's all divided by, and just keep going back to show we're using that equation, 1 minus R bottom, so over 1 minus 4. Okay, so I just filled in a sub 1 is 14 minus a sub 1 times R, which is 4, to the n power over 1 minus R. And now that's going to be a calculator. I just plug it in, and we're done. So 14 minus 14 times 4 to the n. Well, what is n in this case? How many terms are we talking about? Come on, help me out here. We're looking at the problem. How many terms are we going to add up? 7, right? Good. So our n value is 7. So I have 14 minus 14 times 4 to the 7 all over 1 minus 4. Again, that's a sub 1 minus a sub 1 times R to the n over 1 minus R. Now, if I hit enter, it's going to give me this big number. And so, boy, I'm glad I didn't have to add all those together. It looks like they would have gotten pretty big, but our answer is 76,454. Okay, so we found the sum of that geometric series. So far, so good? All right, and you guys at home again, always just write a question or comment in the chat if you want to. Let's do another one together, okay? All right, let's find the sum of the first 8 terms find the sum of the first 8 terms of this string of numbers. 27, second one's 45, third one is 75, and so on. Okay, very similar to the previous problem. Maybe a little bit harder in terms of what numbers we're using. So first we would determine, is it arithmetic or is it geometric? Well, I can see, 45 plus 30 is 75, but 27 plus 30 is not 45. It's not arithmetic. So I'm thinking it's geometric. I'm going to double check by doing the second divided by the first, so 45 divided by 27. Okay, which is 5/3. I have a reduced fraction, or you could do it as a decimal, but probably most accurate is a fraction since it is a repeating decimal. So I did 45 divided by 27. I'm going to do the next one, 75 divided by 45. And again, I'm just checking to make sure that it is geometric. So 75 divided by 45. Look at that, I get 5/3. Now, not only do I know it's geometric, but now I know 5/3 is my R value. So R is equal to 5/3. All right, so we're using again this formula. So a sub 1 minus a sub 1 times R to the n over 1 minus R. So a sub 1 is our first term, which is 27, minus that same term 27, that's a sub 1. And our R, remember R was 5/3 to the n. N is, how many are we adding? It's going to be 8, right? Good. So 8 over 1 minus our R value. So 1 minus 5/3. That's an ugly looking fraction. So I'm glad that I have a nice calculator to help me plug that in. All right, looks like we're okay. We're caught up writing. So I'm going to make a fraction, and on top I have 27 minus 27 times 5/3 to the 8th power all over 1 minus 5/3. All right, so if I hit enter, it's going to give me a fraction, which is correct. But I think when you do it on your homework in Delta Math, and you'll have a problem just like this on your homework, it's going to ask you to round it to the nearest thousand. So I'm going to click and hold enter, get an approximation, and I get 2,370.77. So actually, if I was rounding the nearest thousandth, it would be 0.770. Okay. So 2,370.770. If I was asked to round that on my homework, which it may. All right, any questions on either of those two? Okay, you guys at home look like you're okay. All right, so the first section of your homework is going to be finding geometric series, just like we just did. But I want to review also the next section of your homework, and actually the next couple sections, just because this stuff is all really new to us. Okay, so this is going to be just a little bit of a review question. But this would be a sigma notation question, how it would be asked. Okay, so remember I have my sigma. That means I'm going to add some stuff together. N equals 2 to 60. My equation is 7n plus 3. So this written this way actually is a question. It's telling me add up those numbers, start by plugging 2 in for n, and then plug in 3 and 4 and 5 and all the way up to 60. Now, I don't want to have to write all those out. So first thing I'm going to do is say, all right, well, this, if I plugged in 2, I would get 14 plus 3 is 17, right? And then if I plug in 3 and plug in 4 and plug in 5, and I can plug all those in, but I'm going to plug well, I'll plug in one more. You wouldn't even need to do this, but if I plug in 3, 7 times 3 is 21, plus 3 is 24. Now the next one will be 31, and so on. The reason I'm pointing it out is because it is arithmetic. But I need to do that all the way up until I plug in 60. So 7 times 60, 7 times 6 is 42, so that would be 420 plus the 3 is 423. So I need to find the sum of all those numbers. Well, I can tell it's arithmetic. So I could look back where all 4 of my formulas are together. That is an arithmetic series. So I'm going to do n, which in this case was, what was our n here? Going to be, remember we do 60 minus 2 is 58 plus 1 is 59, meaning I have 59 terms. So it's going to be 59 times a sub 1 plus a sub n over 2. So I'm going to do, I have 59 terms times a sub 1, which was 17, plus a sub n, which was 423, all divided by 2. And that will give me my sum. So I have 59 times 17 plus 423 divided by 2. I get 12,980. Okay, so just a little review, because that, I don't think these are real easy questions, so I wanted to go through that. I'm going to do a couple of quick review questions too. The next one, like the next section of your homework, will be just finding a term. So that'll be of a sequence. If we want to find the 6th term of this, let's say 75, and then 15, and then 3, and so on. So if I'm just finding a term, that means it's a sequence, not a series. And I can tell from this one, it is geometric. Because if I take this and I am looking for 15 divided by 5, 75 divided by 5 is 15, or times 1/5. Okay, divided by 5 or times 1/5. But that 1/5 is my R value. And again, I could get that by going the other way, do 15 divided by 75, or do 3 divided by 15. But I have an R value of 1/5. It's a sequence. I'm going back to where we have all 4 of those together. It's a geometric sequence. So I'm going to do a sub 1 times R to the n minus 1. So here we go. A sub 1 is 75 times our R value, which is 1/5, to the n, which is 6, minus 1. So it's 75 times 1/5 to the 5th power. Times 75 times 1/5 to the 5th. Again, I have a fraction.
which is correct, but to get a decimal approximation for my homework, rounded to the nearest thousandth would be 0.024. Okay, I'm going to do one more similar one. This will be the last one, but this is just like another sequence, but it will be arithmetic, of course, because we just did a geometric one. So let's say we want to find the 35th term of this 12, and then 20, and then 28, and so on.
All right, so I can tell that it is arithmetic. Because we're doing +8, +8, +8. And that 8 is our D value. So this is an arithmetic sequence. So looking back up at our notes, using the formula for an arithmetic sequence. So I'm going to do a sub 1 plus n minus 1 times d. So to find the 35th term, I would do a sub 1, which is 12, plus our n minus 1, so that's 35 minus 1, and our d, which is +8. So I'm just going to plug it in my calculator. So 12 plus 34 times 8. We get 284. All right, so just a quick recap is that we have 4 formulas: arithmetic sequence, geometric sequence, arithmetic series, geometric series. So the geometric series was the new stuff for today. So we did, that'll be like the first section of your homework. The second section, we did an arithmetic series example. That was some sigma notation thrown in there as well. And then we had a geometric sequence and an arithmetic sequence where we were just finding the next term. All right, you guys have any questions on any of those 4 different types? Yeah. Yeah. Perfect. Good question. And you are exactly correct. So the question was, for the sigma notation like this one, how do you know if it's arithmetic or geometric? Because that determines what formula we're going to use, of course. And so the best way to determine that is plug in that number, and that'll give you the first term, and then plug in another one and plug in another one. And I would get, 3 or 4 of those to determine whether it's arithmetic or geometric. So yes, you just plug in a couple to determine which one it is. Then that tells you your formula. And you always plug in the top number to get the last term. So good question. Anything else? All right, so I'm going to have you guys work on your Delta math now. So why don't you work on that for the rest of the period and let me know if you guys have any questions.